All right, guys. So if we are to consider our previous class, we managed to work with average values, working with the average gradient, the average speed on our differential calculus. So also you need to understand the application of the limits, how to apply the limits, and also working with the first principles when using these limits. So what is it that we are considering as a limit? You are given a certain function. Let's say we are given a certain function of f of x, which is equal to, let's just say x squared. So you'll be given a certain consideration where this function that you are given can be represented in terms of y is equal to x squared. And you're asked to determine the limit. They will ask you to determine the limit of this expression of y, which is equal to x squared, when you are given a condition of the x limited to a certain value. So this is showing us x is approaching to 0. X is approaching to a 0. So it's simply, in place of x, we are going to have a 0 squared. X is approaching to 0, so y at that end will be a 0. So the limit are the values that you are given that your function is limited to. So it's an approximate. The value of x, or whatever value that you are given there, will be limited to a certain value. So you need to understand some certain limits. Let's say we've got 1 over the infinity like this. When you work with a condition of 1 over infinity, or a constant which represents any number there over infinity, it can be 2, it can be 3, whatever number that you're given, this is going to be equivalent to a 0. So a constant over infinity gives us a 0, which is opposed by the same sense. If we are given a certain constant over a 0, remember, the denominator is not supposed to be equal to 0. So any number over a 0 is going to give us infinite. It is going to approximate to the infinite. Infinity, we are simply referring to very large values or very big values, like approximating to 0. It's very, very small, very, very small. Consider like 1 over, let's say you've got 1 million, like that, or maybe it's more than that. We'll be having something like 0,0000 and so on. So this value is simply approximating to a 0. It is simply approximating to a 0. So the infinite there is undefined. Some very big. So we're talking about undefined values that you are going to consider in your simplification. So like I said, 1 over, or maybe it's a constant over an infinity, that will be an infinite. But for exponents, if you're given exponential functions, like we have got e to the exponent of a certain function, maybe this is a to the exponent of infinity, like this. As we do understand, guys, any number to the exponent of a 0 is what? It's a 1. So we're not going to talk about that. We are going to consider the infinite. So as a number raised to an infinite value, if you consider that condition, this will remain as an infinite value. A number to a certain infinity, that will remain as an infinite, a to the exponent of infinite. So if we are now given 1 over a to the exponent of the infinite now, since we said this here approximates to infinity, so it means it is 1 over the infinity. And what is 1 over infinity? A constant over infinity will give us what? Will give us a 0. So whenever you are given those negative exponents and it is approximating to infinity, this is like we are given a to the exponent of a positive infinite, like that. So all those fractional exponents, let's say you're given the limit to e to the exponent of negative x, like this, where x is approximating to infinity, like this. Remember, that's a negative there, and we do understand that whatever that you're given here can be written as 1 over e to the exponent of x if you're given this as y is equal to whatever that you're given. So this will be limited to y is equal to the limit as x is approaching to infinity like that. Then we're going to consider 1 over e to the exponent of the infinity, which is same as what we had here, 1 over this. Remember, that's a 0 there. So meaning to say we're going to have 1 over infinity, which is what? Which is a 0. So this can be given as an expression or maybe a combination of terms that you're given. Maybe now you are given y is equal to the limit as x approaches to infinity like this. Then you'll be just given a certain number like 1 minus e to the exponent of minus x. So you're still going to have the same consideration. This is the same as 1 minus 1 over e to the exponent of x, as this is going to be taken for any condition where x is approximating to an infinite. So y is going to be equal to 1 minus, you substitute in place of the x there. So it's going to be 1 over e to the exponent of the infinite, which is the same condition that we had of obtaining as 0. So that's 1 minus as 0. And 1 minus 0 is equal to what? Is equal to 1. So y is equal to 1 when this x that we are given is approximated to infinity. From there, we can simplify using that concept. So you're going to see in the simplification, there later on, we're going to consider other questions that are not direct as this. These ones are direct questions that you can consider. You are just given a certain limit, then you apply that limit. It's a direct question that you can talk about there. Then we also need to consider what is referred to terms that are undefined. Whenever we are referring to something that is undefined terms, undefined terms. All right, so let us say we have got undefined terms. You are given a certain function f of x over a g of x. Then you substitute for any x value that you're given, you obtain a 0 over 0 like this, or you obtain an infinity over an infinity, or you obtain a 0 over the infinity, or is the infinity over 0 like that. These functions are undefined. So in any case, we are going to consider that part is actually going to be seen more if you consider from your N5. We're going to talk much about that, but we are going also to indicate how to evaluate such if it is happening when you are given such undefined. But for now, I just want you to know that those are referred to as the undefined whenever you're given that it is undefined, guys. So the first part, like we saw, the limits are just direct. You are given to determine or to evaluate, or you are given to determine, or you might be asked to simplify. So the question is given in different ways. Calculate the following limits, determine the following, simplify the following. Those are the questions that you might be given. So let's say you are asked to calculate the following limits. Just going to have a few examples to consider the following limits. And we are given the first part, that is the limit as x is approaching to 4 of x plus a 2. So there we are given x is approaching to 4. So it means in place of x, substitute a 4. So that's simply what you're given. 4 plus 2, that will be a 6. So that is when x is approach. So it's just a substitution that is happening there. Substitution that is happening. Just substituting the value that you're given. You are just inserting the limit the way that it is. You are given, maybe that is the limit of 2x, everything over x plus 1, as x is going to approximate to infinity. So remember the infinity concept that we had. We can consider that if we are to substitute the value of x, this is, guys, a product of an infinite, a constant, and an infinite is going to approximate to an infinite. A constant plus infinite, guys, that will be an infinite again. So if you consider this, you're going to see that that's an infinite that you're having there. That's an infinite because you're 2 times infinite. So it's going to be infinite over infinite, which is part of this undefined. But you're not going to leave this because you're saying, this is undefined. No. You have seen that you're obtaining infinite over infinite like this. This is what you're going to do. You look for the term in the denominator that has got the highest exponent. You look for the term that has got the highest power or the highest exponent in the denominator. In the denominator, you're going to look for that term in the denominator. Then you divide by that. Denominator. All right. So, guys, denominator, it's got a lot of things there. Okay. So you look for that term that has got the highest power. In this case, it's just x. So we're not going to see like, okay, just x, guys. The highest power, there is 1. So with the term that you are given with the highest power, you must divide by that term throughout. You must divide each term by that term. Divide each term that you are seeing on your question by that term that has got the highest exponent. Whenever you see an undefined condition where substitution now is limited, you can divide by each term that is with the highest power. When that part can be factorized, we're going to see another condition where this can be factorized. You factorize, but this cannot be factorized. So the only option is to divide by x. So this is what you're going to do. You are going to have this as the limit as x approaches to infinity of you divide everything by x, which is the one that has got the highest power according to our question is x. So you divide by x, the numerator by x. So I'm simply saying this 2x over x. That is our numerator. The denominator, each term, there's x, so it's going to be x over x. There is 1, so it's going to be plus 1 over x. Each and every term, each term, you divide by that with the highest power. So look what's going to happen here. We're going to have the limit of x approaching to infinity of the x and the x here will cancel. That's a 2. Everything over the x and the x here will cancel. That's a 1 plus 1 over x. So this is what we have. So now we can apply the limits. We divided, which is fine. So in place of x, apply the limit that you're given. X is limited to what? To infinity. Remember the condition of the infinite, k over infinite is equal to 0. So that is 1 over infinite. When we substitute this, it is going to give us a 0. So that's a, we have substituted the limit. So we are not going to write limit of, no, we are just going to write our answer 2 over 1 plus. We saw that where there is x here, if you substitute the limit infinite, 1 over infinite, that's a 0. So at the end, we're going to have 2 over 1, which is a 2. So thus, we can now determine the exact limit that we are given. But look, the first part, it was giving us infinite over infinite, and that we can't define, we can't evaluate that. So when you are given just an expression that you have there, divide by the term that has got the highest power, each term divide by that term that has got the highest power according to what you're given. Like I said, there is a part that factorization can be used, and sometimes factorization is not like this one. You have to divide. I'm gonna have another example where we need to divide. All right, let's see this question where we need to divide. Still calculating the limits. All right, let's say we are given the limit of 4x squared plus 3x everything over 2x squared minus 5 as x is approaching to infinite. As x is approaching to infinite. So as x is approaching to infinity, let's see what's going to happen here. First thing, because it's a fraction, so you test for those. Is this part going to happen of infinity over infinity or the end of these conditions? Once it happens, then you must divide, because if we check our denominator, it cannot be factorized. So let's substitute infinite, guys. That's 4 infinite. Guys, if you raise an infinity squared, you add 3 to you are simply increase. These values will be very big. Remember, infinity is very big. So our values, they are going to be very, very big from there. There is nothing that is going to change. So that's infinity there. You put an infinity value, then you just, guys, just to subtract a 5 from an infinity value, just remember, like you've got something like 100,000 or maybe 1 million, then you subtract a 5. Does that affect? It seems like there's no effect at all. So it's still going to be infinite. So in actual sense, when k having an infinity to the exponent of n, and this is positive here, it's a positive that we are given, a positive exponent, which is any positive exponent, that is going to remain as an infinite. But do not forget when it is a negative, because it's going to be 1 over. When it is now raised to a negative, like there is a negative power there, but the infinity is there, but let's say there was a minus there. It is not going to be like that, because it will be 1 over infinite squared, which is 1 over infinity, and 1 over infinity is what? It's a 0. So this one, when having a negative, it will give us a 0 at the end. So you must know that. All right. Anyways, we have seen that we are having the infinity over infinity concept, which means this is undefined. But this cannot stop us, because we can say, I don't know, that's infinite over infinite, so we can't simplify. No. We have to opt, we have to look for ways to simplify this. And what is it? The denominator cannot be factorized, so the only part is to look for the highest power in the denominator, the term that is the highest power. Which term? 2x squared. You divide each and every term by that term. So this will be equal to the limit as x approaches to infinity of what? We're going to divide each and every term. There is 4x squared. Remember, the highest term in the, you consider the denominator. So that is 4x squared divided to that term that is having the highest power, which is 2x. So you can even divide by the 2x there. You can consider the x only, but use the 2x. So that will be 2x squared as it is, plus 3x over 2x squared, each and every term. Also, even the 2x squared. So that will be 2x squared over 2x squared, minus 5 over 2x squared. All right. So this is it. We divided each and every term. 4x squared, the 3x, each and every term that you are seeing there must be divided. So this is what you're going to have. The limit as x approaches to infinity of what? Let's see here. The x squared and x squared is going to cancel. That will be a 2. So this will give us, all right, so that is going to be a 2 plus, here we're going to have the x into the x squared, that is x in the denominator. So meaning, so you're going to have 3 over 2x. Everything over the x squared, this is the same thing. So that's 1 minus 5 over 2x squared. All right. So this is what we're going to have. With this part, we can see that there the limits can now be applied. Apply the limits infinity. Remember, guys, over infinity, k over infinity is equal to 0. K over infinity squared, whether this is infinity to the exponent of positive n, that will give us a 0 again. So we have got a 0 here. We've got a 0 there on top. So that means we are going to have our answer as we have applied the limits. So that will be 2 plus a 0 in this case. 3 over infinity, that's a 0. The 3 there does not work. So that's a 0. 1 minus, that's a 0 also. 5 over infinity. 5 over infinity, guys, that's a 0. So that's going to be 2 over 1, which is simply a 2. So that is the condition that you can consider on a division. On a division, when you see that factorization is limited, the numerator cannot be factorized, the denominator cannot be factorized, because you can have a condition. Even if we to look the numerator, we can factorize x, but look what's going to happen. You obtain 4x plus 3, which is not the same. We saw there's no way, because these two cannot cancel. So on that condition, you divide by the term in the denominator. Take note where the term is taken from the denominator. And that term must have the highest power, which is the highest exponent. All right. So as we saw, this is quite easier. We just have to divide. Sometimes we might not have direct substitutions, and also we might not have a condition where we divide by that. So it depends with the condition, the question. Study the question. Look how the question is given. Let's say we are given something like this. The limit, we are asked to simplify the limit as x is approaching to 3 of x squared minus x minus 6, everything over x minus 3. I want us to see. You were going to substitute the 3 in place of x. That was going to be on top. That is 3 squared minus 3 minus 6. And that was going to be 9 minus 9, which is a 0. So on top, you're going to obtain a 0. In the denominator, you substitute the x, which is 3. That is 3 minus 3. That's a 0 also. That's undefined part. We are back to this part. When you substitute on your f of x and gx, you obtain 0 over 0 like that, or infinity over infinity. Once this happens, you look for the ways now. Is it factorization that you're going to consider? Can we divide by the term? So in this case, if you check, this expression in the numerator, it's a quadratic that can be factorized. Okay, let's factorize this and see. I want you to see what's going to happen there when we have got the term that can be factorized. X squared minus x minus 6. Remember, from your factorization, you're going to have x and x here. Consider the factors of -6, or the products that when you add, you must obtain a -1. There are so many numbers that you multiply to get a -6, which are the products. Talk of -6 and 1, talk of 6 and -1, and -3 and a 2, a 3 and a -2. All these, if you multiply, you get a -6. But it's not of all when you add, when you're going to obtain a -1. So when you add now these products, where is it that you obtain a -1? So you see that -3 plus 2, that's a -1. So you need a -3 and a +2. All right. You factorize this. I want you to see what's going to happen here. Let's substitute. There we just factorized. So you're going to have the limit as x is approaching to 3 of the numerator, which we factorized, and we got 2 brackets to consider them, the x minus 3 and the bracket of x plus 2, everything over x minus 3. This is what we have. But in this case, we can see that after factorizing the numerator and the denominator, there's something that is common, and we can get rid of that, x minus 3. So you can cancel these two. That means we are left with the first type of a question that we had. Remember the questions that we had previous, limit of this. This is, we're just left with what? X plus 2 there. So the limit of this as x is approaching to 3 is what? We can substitute. There's no, guys, this is not a fraction where we test infinity over this. We are no longer having a fraction there. So in place of x, just substitute a 3. In place of x, just put a 3 there. So meaning to say the whole limit that we are going to have will be 3 plus a 2, which is a 5. The whole limit that was seeming to be impossible to work with, because we had a 0 over 0, can be factorized. And you can cancel from there. So let's consider typical questions where the factorization has to play a role in this or in these simplifications of the limits. We can actually do our factorization direct. Even if we are divided by the highest term, guys, the simplification is in your hands at the end. All right, so I want us to consider another part. Let's say we are given the other simplification, determine the limit. If you are given the limit as x is approaching to 2, and we have got x squared minus 4 over x minus 2. So what's the first term? You substitute when x is 2, that's 2 squared minus a 4. In place of x, substitute a 2. 2 squared minus 4, guys, that's a 0 there. 2 minus 2, that's also a 0. So if you say the numerator gives us a 0, the denominator again a 0, that is undefined. So we are going to consider, can we factorize any of these? Yes, the numerator That's a difference of 2 squares. Remember, a squared minus b squared is equal to a minus b into a plus b. So from this, we have got 2x squared, and the 4 is written as 2 squared. So that means we can have 2 brackets from this part. We're going to have 2 brackets to consider as x approaches to 2. We're going to consider x minus, that is a minus b, that is x minus 2, into x plus 2. Just like that. Everything over the denominator as it is. Divide the x minus 3, the x minus 2. So the x minus 2 and x minus 2, which is the same part that we are given. We are going to remain with the limit as x is approaching to 2 of this part, which is x plus 2. So with this, we can simplify further, just like what we were given. This is no longer a fraction. It's just a normal expression. Just substitute in place of x, 2. So that's going to be 2 plus 2, and that is a 4. So meaning to say, this whole limit that we are seeing here was going to give us a 4 at the end. That is what we're going to have at the end. You were going to obtain what? You were going to obtain a 4. So the simplifications are very, very important to be considered. Factorization, you can factorize the denominator that you're given as long this part here is affecting. Factorize your given what? Your given expressions as long it's possible for you to factorize. That can be the best part to work with. So someone could ask, like, what if we divided by the term that is got, it was going to give us the undefined. So that's why we are saying, guys, there, do factorize. Do factorize. All right, let us consider another typical question where factorization can be used. Let's say we are given again to determine the limit where we have got something like this, x minus 2, everything over x squared minus 3x plus 2. All right, as x is approaching to a 2. So if you substitute 2 minus 2 there, that will be a 0 over. Place of x, you're going to have a 2. So that's 2 squared minus 3 plus a 2. All right. So guys, in this case, that's a 2 squared there. So you're going to have 2 squared, which is 4. All right, this one can be simplified direct, guys. This will be a 4 minus a 3 plus a 2, which is going to be 6 minus 3, which is 3. So that's 0 over 3. This one can be simplified direct. So it's going to give us 3. Or remember, 0 divided by 3, guys. That's a 0. This one is just giving us a 0 there. But as we want to consider factorization and see if we're going to have this 0 there, let's consider our factorization. Our factorization, we must consider the denominator there. If you can factorize this, x squared minus 3x plus 2. All right, there we've got 2 brackets. This is 1, so it's going to be x and x. Then considering the products, factors of 2, that will add up to a negative 3. So we need the products or the factors there. There are so many factors for 2, 2 and 1, minus 2 and minus 1. But which part, when you add, you must get a negative 3. That is the negative 2 and negative 1. If you add these two, you obtain a negative 3. That's why we've got a negative 2 and a negative 1. So if you're asked to apply factorization, it's going to be like this. The limit as x is approaching to a 2 of x minus 2 over the factorized part that we had, which is giving us these 2 brackets. So that's x minus 2 into x minus 1. So this is from your factorization concept. So from our factorization, we are going to see that this is going to give us this x minus 2 cancels. So you're going to remain with 1 over here. That's like 1 over this. There it canceled. So you no longer have anything in the numerator. It's just a 1. So that means we're going to have the limit as x is approaching to 2 of a 1 over x minus 1. So let's substitute If this x is approaching to 2, that will be a 2 there, 2 minus 1, guys. This can be simplified. So this is going to be 1 over 2 minus 1, which is simply 1 over 1, and that's a 1. So that is what we are going to have at the end if this is going to approximate to what? To 2. When you are given this condition, you must consider that concept that this is giving us what? This is giving us a value that is corresponding to a certain, I mean, when you are given a 0 there on top, I want to explain that part that happened before. You had a 0 over a certain number, guys. 0 over a certain number exists unless you are told to use factorization. Using factorize is giving us another part. So they will actually have to update you on that part. Factorize. So you'll be given a limit like this, then they will write factorize. They want you to apply the factorization. Factorize, you factorize just like this part. So it's not like always where you are going to apply the factorization. Where it is applicable, use your factorization. Some terms, they are not applicable to the factorization. You do not even apply anything about your factorization. You just need to apply your limits direct. So we are going to have this in much simplification as we move on. I'm just going to have a last question, which is a direct question. The limit of 3x squared minus x plus 1. I said, when you are given something like this, you are not, take note, there's nothing, it's just a fraction, just substitute there. In place of x, that is 3 times 0 squared minus 0 in place of x plus a 1. So that will give you a 1. This one is just direct. All right. So you're going to see that in the next simplification, from the previous part that we had, remember, there's a part that we're talking about the gradient here. It's I'm just gonna hope. All right, I did not like. It's not this one. I wanted us to see the previous class that we had. It's unfortunate that we do not have that. We had a condition where we're working on the f of x plus h minus f of x over h, this and that. And I was saying we are actually finding a derivative. There is the derivative actually that you are referring to. It's a differentiation which is taken from first principles. So there is what we are going to refer to as the first principles, the first principles. All right, so the first principles, it's an application of the derivative in actual sense. It's a limit that is taken where h is equal to 0, where h is going to be approximating to 0 like this, of f of x plus h minus f of x, which is the original function, over h like this. So when you're dealing with the first principles, it's a derivative now that you'll be given, like find the first derivative. They'll ask you from the first principles, So when you're asked like this, it simply means the first derivative, or dy dx, which is given as the first derivative, or whatever that you're given, it represents the limit of h, which is approaching to 0 like this, of f of x plus h. It's a formula that you're also given from your formula sheet. So I want you to see, it represents a derivative, but they might ask that derivative in a disguised manner, that is, determine or simplify. You'll be given this way. Know that it is the same thing. All right, so what is it that you're considering here? I want us to be together here. Let's say a question is like this. I want us to see how typical questions there might be given when we are given such type of functions. All right. Determine the value you might be given. Determine the limit, that is determine the limit, that is the limit of h is approximating to 0 of f of x plus h minus f of x over h of, or for a given function, for the function you are given there, the function to relate to, for the function f of x is equal to x plus 3. Let's say we are given this. Guys, the limit there, we can even take it is the gradient. If we understand the gradient, which is 1. But we are supposed to use, we are limited to something that we are supposed to work with. So this type of a question, they'll ask you find dy dx, or the first derivative with respect to x from first principles. When they ask you like that, you must know what to do. But if they want to avoid that statement, they will give you this question, this manner. This is how you're given. So guys, there's nothing here. Remember from our introduction of the gradient concept, f of x plus h, I was saying it's a function that we are substituting in place of x, where there is x. Where there is x, we are going to substitute x plus h. But there is a plus 3 that is given. So this is in place of x, x plus h. F of x is that original function that you're given. So if you consider this, all right, you're going to see that our solution was going to be like this. All right, so let's see. Remember, I asked you to determine this. They're not saying find the derivative. No, they want to avoid that concept. But still, it's the same first principle they want to avoid. The limit of f of x plus h, which is this part, we got our f of x plus h. That is x plus h plus 3. This is representing our f of x plus h minus f of x. What is representing f of x? It's x plus 3. So it's always good that you put the next term in the bracket. The second part of our function in the bracket. The first one, there's no need there. Minus f of x. What is our f of x? X plus 3. Everything over h. That's our formula. We are substituting in the formula, guys, as h is approaching to 0. So the reason that you do not substitute as it is right now, then you just, okay, where there's h, let me put a 0. The reason is that once you do that, remember 1 over 0 approximates to infinity. So the moment that you place a 0 here, the moment you place it here, everything is now wrong. Why? It's now infinite. So how do you avoid that? Expand your bracket, simplify until you get rid of h in the denominator. So simplify. Okay, let me just write this as a statement. Simplify. So you're gonna need to simplify until you get rid, until you get rid of h in the denominator. In the denominator. That h in the is the one that we need to remove, because it's limiting us to use these limits, because we do understand that the moment we substitute a 0 there, that's if we have not calculated anything. So it is limiting. So we have to simplify until we get rid of that. How? Okay, let's simplify. The limit, remember there, as h is approaching to 0, is going to be, expand this, that's the one there. So there is no need, it's just x plus h plus 3. Expand the brackets of the second bracket here by a -1. -1 times x, that will be negative x. -1 times a positive 3, that's a -3. Everything over what? Over h. So this is where we are. Still, we are having the h in the denominator. So the question is, how can we get rid of this? Okay, let's move on. Let's simplify. The x and the x cancels. The 3 and the 3 cancels. Actually, we talked about these from the gradient concept, if you still remember. So it canceled everything. We are just left with h. So this is h over h. And unfortunately, in our question, we are simplifying to an extent that even that h is no longer there, even in the numerator. In the normal circumstance, you are supposed to obtain something like this. The limit as h is approaching to 0, you obtain something that he has got h somehow there, where you substitute a 0. But in this case, it is not happening. No, it is not. We are just left with a number there. It's just like the limit as the limit of h is approaching to 0, and you have got a number which is 2. There is no h there. No, there's no h. It's not 2h. It's not 2 plus h. It's just a 2. So we are not substituting any h. Okay, guys, this is it. When you are given something like this, f of x is equal to x squared plus 2. Then when you are finding f of x plus h, how are you substituting? You were substituting where there is x plus h squared plus, where there's 2, you are not substituting anything because it's a constant, it's a number. So that is not supposed to change the meaning of our simplification. Even on this part, there is a number there, not h. So the moment you substitute your h, which is a 0, there is nothing that you're substituting there. There is nothing. So it's just going to remain as a 1 like that. So in actual sense, this is our simplification from what we had that was going to give us a 1 at the end. So like I said, our limits are supposed to be applied. We can have this as a derivative, which is taken out of the limits that you are given direct from a normal algebraic expression. All right, let's consider another part again of the same sort, where this formula is to be used. So it's a first principle disguised. That is the case. All right, determine the limit of this given the function this time. Let's say we have got our f of x is equal to x squared. All right, this is our f of x this time. So I want us to have the same concept and see what is going to happen if we apply the limit concept or the first principle concept. So this is what we have. F of x this time is given as what? Is given as x squared. So what are we going to do? As we can see from our formula, we have got f of x and also f of x plus h. So in this case, we have already our f of x, which is x squared. We are going to need f of x plus h, where we substitute in place of x, we substitute what? X plus h. All right. F of x plus h, in place of x, we substitute x plus h. So this is going to be x plus h squared like this. All right. We talked about this actually from the gradient concept, even guys from our normal expansion. Remember, this does not change the concept of a plus b squared. A plus b squared is a squared plus 2ab plus b squared. That is the first squared, and so on and so on. So in this case, this will be the first squared, x squared plus 2ab, 2 times a and b, 2 times x and h. So that's 2xh or 2hx plus b squared, which is the last term, squared, which is h squared. All right. This is where we are. That's our f of x plus h. We can just leave it like that so that we can substitute into the formula. So like I said, that will be our solution here. All right. So you're going to have the limit. This is taken from this limit. So you're going to have this as the limit as h is approaching to 0. So you're going to have the limit as h is approaching to 0 of what? F of x plus h. F of x plus h, which is the one that we simplified here. So we simplified our f of x plus h. Let's hope this is going to be clear. All right, so this is our f of x plus h. You take this one as it is, x squared plus 2xh plus h squared. All right. Minus f of x. And our f of x is just a single term, guys. This is just x squared. But if you do not want confusion, just write it in a bracket so that you do not have confusion to say, where am I going to put a bracket or where am I not going to have this? All right, where there's an expression, is a term, just put your bracket so that you do not have confusion there. So this is it. We applied our limit concept, but we still have to simplify, like I said before, until you get rid of the h in the denominator. Until you get rid of the h in the denominator. All right. The limit as h is approaching to 0, you're going to substitute here. As you can see, there are some terms to be considered, x squared minus x squared there. That will cancel, and you've got something like this, everything over h. I explained that a plus b over c is the same as a over c. If you're given this, a over c plus b over c. So you can actually use the same concept there. Remember, what we need is to get rid of the h in the denominator. So by getting rid of this h in the denominator, that will be 2xh over h plus h squared over h, like this. So let's divide. The h and the h cancels. The h into the h squared, that will be h. So I want you to see what is happening, which is different from the previous condition that we had. This is going to give us a 2x plus h. Remember there, we are remaining with h. The previous case that we had, we were limited to a condition where we do not have anything left with h. And on that condition, you just have to take the number that you're given as it is. But in this case, there is h. What we wanted here was to remove the h in the denominator. And as you can see, we no longer have that. The h that we have, it's not in the denominator, it's just an h added. So the limits can be applied when h is approximating or approach to 0. So meaning to say, in this case, we are going to have, as the limit is being applied, that will be 2x plus s0, like that, which is simply 2x. So it's actually a derivative in disguise that we are working with. So actually the first principles, I think I had a separate topic of that. Just make sure you go through and see. But if we see that that part is not there, clearly presented as a topic, first principles, then let me know about that so that we can work with more questions. But this is under limits. You are working with as a limit, but it's a first principle that is hidden with this part. So these are the typical questions that you need on limits. Let's revise as much questions as we can. Then we are going to have typical exam questions that relate to what we are having on these derivatives. So we're going to consider also the other part in our next class.